Hello friends, how are you? Hope you have been okay. In the previous mathematics lecture we talked about the first law of the power, and in this video we're going to cover the second law of the power. Okay, what really the second law of the power says, if you haven't checked that video out, the first law, then go check out that video, then come to this video until you understand this very much easily. And this video is totally depending on the first law. Okay, these are kind of related things to each other. That's why you shouldn't have to be aware of the first law, then come to this video. So the second law says that to multiply different bases with the same exponent, keep a common exponent and multiply the bases with each other. So this law says that if you have an expression whose exponents are the same, okay, not one expression, more expressions, but their bases are not common, not the same, what you shouldn't have to do, just and only keep the same exponent and multiply the bases with each other. Let's go and check. The general form I have written here, okay, we have base A, B. Of course, they are not the same. Multiply different bases, okay, they are different to multiply them, but the exponent we have been having here, they are the same. What we shouldn't have to do to multiply A, B with each other and having the same base, which is n. Let's do some examples, okay? Examples, the first example, we have 2 to the power 3, okay, multiplied by 5 to the power 3. Isn't it? Of course, this is the first law, okay? We have the same exponent, but different bases, okay? What we shouldn't have to do to multiply the bases with each other and keeping the same exponent, okay? 2 multiplied by 5 whole to the power 3, okay? 2 multiplied by 5, 10. 10 to the power 3 equals 1000. Okay, 10 to the power 3 means 10 into 10 into 10. 10 into 10, 100. Into 10 equals 1000, okay? The second example, let's do it, okay? We have 5 to the power 10 multiply 2 to the power 10 multiply 3 to the power 10. Look at the exponents. 10, 10, 10. Of course, we have the same exponents, okay? So keeping the same exponent, which is 10. We're having, okay, different kinds of bases, okay, which is 5, 2, 3. 5 into 2 into 3 equals 5 into 2, 10, 10 into 3, 30. 30 to the power 10. It becomes bigger number, okay? You could simplify it by your own, or you have a calculator, you can find it soon. Look at the third example, okay? 3 to the power 4, 2, 3. Of course, we have different bases, but if we look at the exponents, 4, 4, 4, of course, they are the same. So what we shouldn't have to do to multiply the bases and keeping the same exponent. So 3 over 4 multiplied by 2 multiplied by 3. Having the same or keeping the same exponent, okay? This becomes 2 and 1, okay? 3 into 3, 9, 9 over 2, okay? 9 over 2 whole to the power 4. We could also write this 9 over 4, 2 over 4, okay? This is the final answer we are having. The last example I'd also like to do for you, okay? Try to copy these examples, and you shouldn't have to do by your own. Take its note, okay? Everything is understood by the examples. 8. Let me do it here, okay? Look at here, x, y, z. We are having totally different bases. X into y into z. Having the same exponent, okay? This is the final answer of this question. I hope you got it, okay? This is the second law, which says to multiply different bases with the same exponent, keep a common exponent, and multiply the bases with each other. I hope you got it, okay? Let's move into the third law. Look at here, okay? The third law of the power. The third law of the power says to multiply expressions with both different bases and exponents to simplify each and do multiplication. This law says that if we have expressions, neither their exponent might be the same nor their bases. What we shouldn't have to do to simplify each expression, then multiply with each other, okay? The general form we have for this law is a to the power n multiply b to the power m. These are, okay, bases, okay? So a is not equal to b, not the same. This is our exponent. N is not equal to m, not the same. Both bases and exponents are different, okay? What we shouldn't have to do is to a to the power n to simplify a to the power n, whatever it is, then multiply b to the power m, okay? Let's do some examples. The first example, 5 to the power 3 multiplied to the power 2. 5 is not equal to 2, not having same bases. 3 not equals 2, not having same exponent. What we shouldn't have to do to simplify this, then multiply, then simplify this, okay? Look at here. 5 to the power 3 becomes 125, okay? 5 to the power 3 equals 125. 2 to the power 2 equals 4. What we shouldn't have to do to multiply these both, okay? 125 into 4 equals 125 into 4. 0, 4, 2, 8. 8 and 2 is 10, okay? 4, 1, 4, and 1, 5. 500, okay? Our final answer is 500. Let's do this example. We are not having the same basis, okay? Here we have 9, here we have 1 over 9. They are not the same. And this is squared, this is also squared. So what we shouldn't have to do, we have the same basis, okay? Let me just put here 1, okay? 1. 9 over 9 to the power 2 becomes 81. 9 into 9 becomes 81, okay? Multiplied by 1 to the power, this 1 belongs to 1 and 9, okay? 1 to the power 1 becomes 1. 1 to the power 9 becomes 9. So we could here simplify more, okay? 1 and 9. 1, 9, 9, 9, 9, 81. So 9 into 1 becomes 9. This is our final answer. Just let me do the last example. Look at here. We have 4 to the power 2 multiply 2 to the power 3 multiply